All right, guys. So today I got Gregg Jones, owner and founder of Tial. Tial has been making wastegates for what, 25 years now? And blow-off valves.
93. So,
Okay, so that's freaking crazy. Because what was early boost control for you then? Like, what was?
early on in the industry, because I started my first, performance business. Okay, where we're doing performance work in '84 was. The only guys in the market were for wastegates was essentially Turbinetics, HKS, Gregg. And I recognized that the product may be able to be improved. And came from a manufacturing background, so I said, well, someday I might make a wastegate.
That's funny. So it was all JDM almost at the time.
The only non-Japanese, because obviously Japan adopted turbo performance well before the U.S. did, and so the better brands, and they were better, better product than because they've been doing it longer. Obviously, they started developing it earlier.
It's just weird to think that like turbos were such a JDM thing at that time, where people like V8s are just like, that's stupid. Because I wasn't in the car world at that time, so it's kind of interesting to get that snippet of history of like what the two sides were doing.
Yeah, my base, coming from my initial performance work was basically based on Porsches, which had turbos, right? So I was a big turbo fan even from early on, having been bit by the Porsche bug and wanting to do, thinking they're kind of cool and unique cars. I'm like, they had turbos. So that kind of, again, more interest in turbos, as time went on.
The Porsche turbo stuff is pretty awesome. I noticed that a bunch on your website. I was like, oh.
Yeah, so today still we're very, very Porsche-centric in terms of a lot of the product we develop specifically for those cars.
So you took what basically HKS was doing and you saw it, or Gregg and HKS and that kind of stuff, and you were like, how can I?
Yeah, I looked at it as, what could be improved, right? It wasn't that it wasn't a quality product. It was like, but I think we noticed there were things that thought could be better about the product, and that's why in '93 I decided I would start working on the wastegate. Had the first production wastegate in '95 at SEMA, so that was the first sale of our wastegates. But it started in '93. Started making the product. And
what was the primary use of those then at that point? What cars were they headed
believe it or
up
not,
on?
it was a Porsche fitment, right? So it had the 911 turbo bolt pattern. It was the market I knew, right? I came from Porsche.
Was that the 2-bolt flange?
No, it's a 4-bolt flange.
Okay.
Yeah, so a 4-bolt flange. But the leader in the market, so 95, right, is kind of Fast and Furious, I think is the first. Around 95, I think is when the first Fast and Furious movie came out, right?
That's probably when people first heard the blow-off valve noise.
I mean, blow-off valves, and like turbo Hondas. And so the turbo Honda market was just starting to come on, like in Southern California, where guys were doing, kits for Hondas, right? And I'd still been doing Porsche stuff primarily. That's all I knew, primarily. There was no real big, movement yet in aftermarket. Right, aftermarket turbos. There were a few guys who were doing them. HKS, again, back being in Japan, and they had Garrett had manufacturing in Japan. They teamed up. So the performance leaders in turbo at the time probably were the HKS-based units.
So you were thinking, that's crazy that you were thinking of developing these blow-off valves before people were even really turboing their cars.
I just saw, really simple.
That seems like real weird forethought almost in a way.
Yeah,
like,
I mean,
it was weird, but like it seems like, I don't know, it just seems like it kind of
trying to develop product for the cars, the kits themselves. So my first business started in 1985 with Porsche stuff. Was that availability of parts was very low, and turbochargers were almost difficult. Like you were going to go get something that came off a diesel or something, because that's where most turbos in the United States were produced for diesel applications, non-automotive.
Yeah.
So, there were a few guys, and Turbinetics would be one of those guys early on. Bob Keller, he was, started Turbinetics, and he was basically he was part of the Garrett distribution scene at the time, and would take various parts from turbochargers and basically create a more performance version of those turbos. And so
they would modify.
Yeah, so he would take various parts that would fit better for not a diesel application, but for a gasoline performance application. So, recognizing, again, limitation of parts was the primary one. The materials that were selected, I came from a materials background. So I'm like, man, why aren't these things made in stainless steel? Better quality, machined aluminum. Everything was cast. I'm like, machined aluminum and anodized, would be a nicer product. And, kind of on that basis is where I kind of moved forward. So in 93, that's when I said, okay, I'm going to go ahead and start developing the product at that point.
And when you were developing this product, how much were you looking at what Porsche had to modify it and what HKS had, or was it like, I'm just going to kind of start from scratch?
Because I'd originally produced a kit with a partner of mine, we did Porsches, right? So we saw Porsche application. And one of the main limitations on the original Porsche wastegate was the size of the actuator. So it was a very large actuator, but there was no real electronic boost control at the time. I mean, OEMs were using it on race cars, but in the aftermarket, HKS was one of the first. It was too big, right? So one of the improvements was basically make the can of the top of the wastegate smaller. So they had better boost control. That's kind of, again, just kind of recognizing things that could be improved for current market, current day. So.
It's just weird hearing all about this stuff then, and how it's evolved to now is so crazy, because I'm sure what you saw then and what you thought the future was going to be is completely different than...
Oh, definitely starting what I did in 93, had no idea where the market was going. Like, I only saw my little niche market of guys in Porsches, right? And I'm like, if I make, a few of these a year and continue to make the other products I was making, that was fine. It wasn't like I saw this all of a sudden massive boom in the aftermarket that kind of was fueled by, again, back kind of the Fast and Furious, the movies. It's surprising how much of influence that had in the market.
That's a funny domino effect.
It is, but you would think, it's just a movie. But reality is it caught on in a big way in the U.S. in 95 and then on.
I think it's burned into a lot of people's brains, that initial blow-off valve sound that you can hear in the movie, and then when they open the hood and there's all the blue lines everywhere, and you can see the plumbing of the blow-off valves and stuff. I think that's a very...
And that came again back from the Japanese HKS and Greggs of the day, right? That whole very detailed engine bays. It was that was the thing that people wanted, but performance too. It was like the Honda was the new Chevy, a small block, right? And,
even that first movie, they didn't include anything LS based really, or anything.
Because domestic. At that point, almost nobody was doing anything with a V8 turbo wise in the market.
But even racing in that movie, there was no Corvette racing, there was no Camaro in that. It was just all Japanese.
All Japanese.
It's funny to think back that they kind of skipped a whole side of the car market.
It just wasn't really being applied. I mean, today you see it being applied very broadly. All engines are going to see turbos today, but not back in the 90s. No, not so much.
Yeah, the no replacement for displacement stuff came about.
It's something that still holds true, I guess. If you're having an NA motor, bigger generally makes more power. So.
It's great until then you see the guys that also now have turbos with all the displacement, and then you're like, now you kind of got both. It's fine when you got a 2-liter and you're like, my replacement for displacement, but then when you're like, now he's got a 600 cubic inch motor with twin turbos.
Yeah, and there's been a lot of modernization in U.S. or domestic engines too, obviously with Ford and so forth, having dual overcam engines and making modern engines, right? Yeah. Direct injected, all those things. So the market continued to grow, obviously, as those things came into existence. And we made our first blow-off valves were really in late 90s. I think about 97 was the first blow-off that we did. We were primarily wastegate. Then we moved on to more wastegate fitments, which would have been like the Turbinetics. Delta Gate was a popular fitment for the market. So we decided to make the 2-bolt flange at that point, which is originally, most people don't know, was essentially a Roadmaster application. So it came from some diesel application, but that 2-bolt pattern had carried through from decades before that. And it was a Roadmaster that was the actual fit pattern of the 2-bolt wastegate.
I think that 2-bolt wastegate brought a lot of pain to a lot of people.
Well, we did. So again, we looked at that.
Not just because of you guys, but just in general, because those things are, it's tough when you're throwing a bunch of boost at those.
The 2-bolt pattern did have some limitations. What we did in our design, which to try to improve that, was we made a different design so that we could reinforce the bending of the flange, also in a gasket and a valve seat design to reduce the leakage issues that were kind of inherent in the 2-bolt design. So, that was our launch into that, was like, how can we improve the product from where it is? And again, it was not faulting the previous product. It's just that's what it was, and it worked for its previous application. But when you get to performance, it could have some improvements.
I've seen them still work. Mm-hmm. I still see that work, but it's crazy the difference in once you step to a V-band.
We still sell it today, believe it or not. We still sell what we call the F38 today for us, but we still sell it. Now the volumes are significantly lower than obviously V-band is obviously dominates the market today. So
yeah, especially the boost volume like that we're trying to push through these.
Well, not
cars.
having gaskets is a nice thing when you have a V-band. So you don't have metal to metal sealing is beats most gaskets any day. So we moved, we were the first to introduce, well, I say first. I don't know if that's true. Early in the 2000s, we decided we were going to do a V-band wastegate, the V44. I think we introduced that in late 2003, 2004 timeframe. Seeing that, the market could use a better fitment.
Still competing with basically Gregg and HKS at the time?
They did not have one yet. Okay. Come out wise, HKS came out first in Japan with a V-band version, and then so they were all kind of in the 2000s, introduced at that point in time for V-band.
Where did the V-band come from? Did that come out of a different level of manufacturing? Was that used somewhere else, and you guys brought it into?
Just other than the basic design, but the size and the fitment was really 100% ours. There was no existing design in the aftermarket really in the sizes that we produced. Now, HKS had a larger wastegate at the time. They had a 50 millimeter and later came out with a 60 millimeter. But on the smaller side, 38 millimeter and 44 millimeter, which is what most people needed, at least at that point in time in the market, there was no fitment. So we created a fitment at that time.
That size and everything.
And it is today the fitment that most people have. Like, so if there's a competing wastegate product, it's actually the same fitment as ours. So we kind of generated that 38, 44 millimeter. Mm-hmm. There's sure some variations in numbers today, but it interchanges with several of the other manufacturers who make wastegates today.
But when you first decided to introduce V-band, did you was that obvious? Was it like, oh, there's V-bands already on like Porsches and stuff?
Or was it like... in fact, Porsche didn't have anything V-band. Everything was flanged with bolts.
So you had to like kind of hunt around for this style
Well, we just created it out of...
Just V-band in general.
In general. So V-bands existed, but they were generally used on aircraft.
Okay, that's what I was wondering where you kind of pulled that from.
So the basic knowledge of V-band flanges were called Marmon design flanges, which were V-band, which were in aircraft, essentially. So just reapplying that and designing it to work for.
Okay, that's cool. That makes sense. I was wondering because I didn't know if that was like, somebody used that already in automotive and you kind of adapted that, but that's cool that you ventured out of automotive to find something that was superior.
Again, back to the 2-bolt was like, it was not, the flange design was not a good design. To do what we were doing in the performance, high boost levels and gaskets, right? You did the best we could to make it better. But at the end of the day, a V-band, it was 360-degree clamping. When you do bolts, you have a space between each bolt where the gas wants to leave, right? Mm-hmm. It's gonna warp the flange, the gasket blows out. That's where it does. Where in a V-band, you get 360-degree clamping force. So it's just a much better design for any kind of tube that's going to hold pressure.
Well, it's obvious now also, but like when you were first trying to figure all that stuff out, I'm sure it wasn't as obvious.
We'd seen it on some race cars. So actually, of the day, back in the day, like when F1, so being a big F1 fan, like Honda and a bunch of other companies in F1 had actually, moved to V-bands. And so you saw them in racing. In that time frame, not in the aftermarket, but the OEM race teams were applying those on like F1 cars at the time. Indy cars were using them. So
the trickle down effect.
So it was trickling over from OEM Motorsport. Was like, these all have V-bands on them. So I would say also seeing that in Motorsport going, but nothing exists in the aftermarket. So that's kind of why we pushed towards the V-band, because it's just better performance and works better.
Yeah, and the clockability, of course, is
you get
unmatched.
Better adjust, there's a lot of things that are pluses for V-band. So it's kind of a natural, I think, progression to that.
And V-band. Even now they're starting to get phased out in a couple different spots, I guess, when you start to see like not on wastegates and blow-off valves, but like on putting my turbo kit together isn't as V-banded because they're so stiff. So now you can kind of switch to like a Vangean style clamp or something. But even on all turbo applications, they're still loving V-bands.
Yes. There's a few areas where it's a little difficult to apply, like undivided housings for like turbo flanges, right? So if you're going to have a popper fit with like a T4 V-band, not V-band, but it's the T4 flanged. It's hard to do a V-band flange in a divided inlet on a turbo housing. Can do it, but it's a little hard to apply. So
that's tough in itself, the T4 flanges, because they're inevitably as tight as can be to try to get things together, and it's heavy. So
it carries over. So for some of the problem with it is that it was a carryover design from many, many years before. So then you keep trying to work around that fitment to make it better. But it's still, at the end of the day, there's always that when you're trying to put the turbo on the car, there's one bolt you can't get to, right? It's always like, I have a special ground wrench to get to that bolt on the fourth bolt. 3 tighten, 4, there's a pain.
And everybody hates the change. But I'm sure these companies could do so much better if we were just like, okay, just make the change, just do it.
And, it's become more popular, obviously. The popularity of divided T4 flange housing is still very popular in race applications, or we'll say racing in general. Street cars are using it too, but it comes from, a carryover of divided housing is
that streetcar term is very loose.
Yeah.
It's
there's a lot of variation in that, so it's kind of hard to say that.
Like 90 millimeter turbos are on streetcars, so like
if digging into the
horsepower.
Digging into the only thing that you really divided housings came from diesel engines and low speed operating diesel engines, and there is a significant benefit to the divided housing in diesel. This is where it came from initially, is having that pulse energy at low engine speeds to help the turbo spool up on those cars. Today's probably less on high RPM, but you still get the benefit of a divided exhaust system. So from a tuning standpoint, from an engine standpoint, you can still see some advantages of a divided housing due to tuning, separation of the exhaust pulses. By having a divided exhaust system.
Yeah, it makes it a little cleaner depending on your manifold design and stuff. Because my 2J has divided on it as well, and then it's 3 into 2 into the divided, so it's kind of like half the motor.
Yeah,
it's
almost 3 cylinders going into one side, 3 cylinders goes to the other side.
Yep.
Again, you can capture that pulse energy, but at higher speeds, it becomes less of an advantage. It's more an advantage in below 3,000 RPM on most engines.
I was going to say on my car, it gets up to 5,500 RPM and then leaves there and then doesn't drop below that.
Doesn't drop below it. So it's like, at that point, it's less of an advantage. But again, there's still that aspect of tuning. And for the engine, you get more balanced. You don't get crosstalk between cylinders, right? So it helps from a tuning side.
Would you say lately you're more housing focused, or because I know you do a lot of those?
Obviously, we started off in wastegate. We started into turbo housings. That was one of the other thing that we started in 2003, which was V-band stainless housings. Nothing existed in the aftermarket. Back to the same reasons. V-bands are much easier to apply for most cars. Better clamping, less exhaust leakages, and so we introduced V-band turbine housings. In 2003, and
are those triple V-band? Are they?
So it depends on the turbo cartridge. So most of those at the time were not V-band. The smaller ones. So the GT, we'll call them the GT turbos of the time, which were Garrett-based turbos. All were bolted, where the CHRA bolts into the housing, but V-band in and V-band out on the exhaust side.
Okay.
The larger frame turbos had V-bands, so GT42 and higher and larger all used a V-band, or I say all, most did. Used the V-band connection. Then it was 3 V-bands, one on the CHRA, one on the inlet, one on the outlet.
That makes it real easy once everything.
It's a lot. Again, you can get to one bolt real easy. Again, back to bolts can be a real, not fun, right? Especially if you're working on the car, right? Having bolts to get to, there's always that one that gives you the trouble.
Yeah, and when we're talking race cars, everything has to be a service item.
Right, and again, you got one bolt, and you get it off with a V-band where you don't, not unbolt, it's, more difficult.
You never know where you're going to have to take the car apart. Often it's at the track with limited tools or in the dark, basically. So
and even compressor housings today are going to, has been applied there too. So that also helps the racer if they're doing like inspections for turbo sizing and things like that. Being able to get the compressor housing off easily is an easy thing.
Well, that's a big thing now in almost all forms of racing, where you have to take your compressor housing off before you make a pass, which is insanely difficult for some because location-wise, just to start, but then you have to drag your car up there, measure it. It's a whole thing.
Yes, it is. It is a thing. So V-bands will continue to become, more popular for all sizes of turbo, I think.
So then the stainless steel back housings, what kind of benefits, what was the...
Primarily because they're investment cast housings. The primary bit, besides the V-band connection sealing and usefulness of that, is the interior surfaces of the volute are smoother, so that you can gain some turbine efficiencies from smoother internal passages on turbo housings. So that's the other advantage.
What did you call that? The volute or
the volute, the turbine volute. So that's the passage, the internal passage that the gas enters the turbine wheel.
I have not heard that phrase.
I guess it's the technical
often.
Engineering term. It's a volute. It's a shape designed to very evenly introduce the gas 360 degrees into the wheel. So an optimized volute design provides better performance also. So if you have a more accurate design and the internal surfaces are smoother, you can gain turbine performance.
And it's probably lighter too, right?
Lightness comes primarily, you can make a light part, but if you're going to make a part that's safe, isn't necessarily going to be lighter. In today's turbo world, it's the safety part of it, of the performance, is you want to make sure it's safe, right? So you can make it light, but, is it safe being light?
That makes sense. Yeah, I mean, there's no need to shave a pound or two off of a back housing just to make it a little bit lighter.
It isn't really in most applications for performance in the aftermarket. Super light is it's nice, but is it required? Probably not from a weight standpoint. There's some advantages, but safety being the primary one, is that we want to make it safe for the customer. So our housings are not the lightest housings in the market, but that's because our bigger concern is safety. And so through materials, you can make them lighter, but then you have cost to play with. So, I mean, technically you can make a turbine housing out of turbine blade material, right? Then you can make it lighter because that's the strongest alloy you can produce, which would be make it a vacuum cast turbine alloy. But you wouldn't want to buy it because it would be like $2,000, right? So
what would that material be then?
It would be an Inconel, like an Inconel 713 or a grade like that, where it has very high strength at high temperatures compared to what you'll see in most turbine housings today. You're going to see a 300 series grade alloy of some kind in turbine housing. So it doesn't have a turbine alloy at the same temperature is going to be 10 times stronger.
Is that also about just not, because even if they expand just a little bit under temperature, is that a lot of it?
It has to do with just pure mechanical strengths of the materials and what those strengths are at temperature, right? Because it's hot. So even though you see data published for these alloys, they're usually room temperature, not when the turbine is operating at 1700, 1800 degrees exhaust gas temperature. The housing will be 1400 degrees or 1500 degrees easily. If you're putting a jacket on it, like a lot of guys want to put the heat blanket on, you're going to raise that temperature more. So as you continue to raise that temperature, that material gets weaker.
I've always avoided the heat blankets. I don't know if that's good or bad. I've heard at spool time be a little faster, but then it always seemed like it kind of rusted them out a little worse. Like
especially on cast iron. Now, so if you're using an iron housing, the problem is that ductile irons transform their grain structure at 1400 degrees Fahrenheit. And now you get this real scaling effect, right? So it scales the housing it has a growth, and it causes scaling and other problems with iron housing. So I would say probably not the best idea to put it in. You're going to have a shorter housing life, is what's going to happen. The blanket is obvious for other reasons, to try to keep your underhood temperatures lower, which has a negative performance effect, right? You're sucking in hot air into your engine potentially, depending where your inlet is. So
I'll melt my paint on my hood.
Or you're basically catching other stuff in the engine bay on fire. So you need to have a heat blanket on it to keep stuff from like melting other items in the engine bay. So there's pluses and minuses to heat blankets. But it just really depends on the application. So
would you say a coating would be a better route?
It's kind of a middle ground, right? The blankets will have significantly better reduction in heat transfer or thermal. You're blocking that. Ceramics are maybe a good middle ground between nothing and having something. So again, it cuts the hood temperature down and radiated heat down. But it's kind of not as good as the blankets would be in that respect.
Yeah. Huh, that makes sense. I've heard a lot of people say about spool time helps when you keep the heat in a little bit, but
it's true. You get some exhaust gas cooling that happens between the engine and the turbo, so the more heat or energy you can deliver to the turbine is going to help that spool response. So yeah.
I've often wondered about just making the housings longer, like, putting the putting the inlet side of the turbo and the exducer side
packaging maybe
a lot farther away.
Right,
like on a 2J, you could put it at the beginning of the engine and the end of the engine.
True. So
just a long shaft.
Yeah, make it a lot longer. Get the hot source away from the cold source a lot further.
That would probably be like where the engineer is like, this is ideal versus what a mechanic would actually work on.
Yeah, and you could still actually, instead of putting it on the turbine, you could put basically thermal shielding on your compressor side, right, to keep that radiated heat from the turbine housing mitigating into the compressor side.
Well, most people use blast shields now on a lot of the bigger turbos.
Yeah, I mean, and that's again, back to safety kind of thing, right? It's a good idea to, you don't want turbine wheels exiting turbine housings. So it's back to safety, and you get maybe a couple benefits from those items. Haven't seen too many of the blast blankets, but
they're on the bigger ones. But I've seen more exhaust wheels come out exhaust than I've seen anything.
Two different failure modes there. Yeah. So when they exit the housing radially, out the outside of the housing, peripheral outside, that's typically a hub burst, or the actual center of the wheel is coming apart typically in about 3 pieces. So they call it tri-hub burst. That's when it comes out that way. When it exits the other way, something else has happened to the turbo. Generally, a lot of things can cause that, where the turbine wheel will shear off from the shaft. Could be a piece of debris coming into the turbo. Bearing failure causes a really abrupt change in speed within it, and you have this massive force on, you have a lot of inertia on the turbine. So if the compressor side starts to slow down for some reason abruptly, it can just literally shear off the wheel, off the shaft, because it's got so much inertia. That goes out the turbine exhaust, yeah.
Yeah, it seems like some cars do that a lot more than others. Like GTRs are really known to shoot their exhaust wheels out. I don't know why that's a thing. I don't know if I want to
blame it on GTRs. I think you have a lot of really high-performance engines going on in GTR, so I think preponderance of the number of cars, you would see maybe a larger number of it happening on that particular car, not because of the car.
I was thinking more as the turbo sizing they end up using, where they have kind of big engines, but not really, because it's like the 4.1 liter V6. So they use small size turbos and they overspin them most likely.
Overspeeding has a lot of potential problems, right? So failure modes are, could be a bearing failure, could be, something else, or compressor side failure, debris getting, these are at racetracks too, so you could potentially have debris getting into the, it's one of those things, you get a small chunk of rubber entering your compressor wheel, you can jam up the compressor wheel, it will bend it, and then you have an abrupt stop of the turbine wheel shaft. And again, the Inconel shaft head has a tremendous amount of mass in it compared to, and it literally just shears it off. And that's why you'll get that to happen. So failure modes are varied, but there's a lot of things that could cause it. But yeah, that's why you see turbine wheels exiting turbine housings out the exhaust pipe, because of various failure modes that can happen.
Yeah, I always fear that with aluminum exhausts as well, is when people use aluminum exhaust versus like stainless or titanium.
Well, there is a move to obviously, I think most organizing events now are like, hey, you really need to have something that can stop a turbine wheel from coming out the exhaust pipe. And granted, aluminum is going to have very little resistance to a turbine wheel exiting, but I've seen them go through stainless, downpipes too. There's so much energy stored when a turbo is turning 150,000 RPM. If you calculate that energy, it's a tremendous amount of energy. So it's very difficult to stop it because of that stored energy from the speed of the turbine shaft. So you're going to see a lot more of these cross-bolted, pieces that go in behind the turbine to try to slow it down or keep it from exiting. And you don't want anybody, again, back to safety, and you don't want anybody getting hurt. So I think you're going to see it more widely applied. I think coming this year, there's going to be significantly more organizers like, hey, you need to be able to keep that turbine wheel in the turbo.
But even like, I guess turbo manufacturers, some of the bigger ones are putting the 4-bolt flanges on the backside of the turbo housings, but then that's only on the big turbos, on like your street style.
I mean, it can happen, kind of on any turbo.
It can happen, but
it can happen on any turbo. So
you only see it on the big turbos, like
because they're really pushing the product really hard. Like they're it's inlet restricted turbos are run to essentially beyond design speed, because that's, if you try to stay within the design limits that materials allow you to design to, you're going to be going slower than it. Everyone's willing to push their turbo until it breaks, essentially. Yeah. Like, we're going to keep going until, what's the weakest link? Mm-hmm. Either I have an engine problem, transmission problem, or I have a turbo problem. I'm not sure which one's going to break first, but, that's the nature of racing, right? Like, you're going to push your stuff as hard as you can.
Something has to break.
Something's going to break.
You're not trying hard enough.
Right. So you fix that problem, then the next one comes along, right? So that's the nature of racing, but, and trying to make it safe at the same time. It doesn't have to be unsafe. So.
Well, even some of these modified turbos to get as much weight off of the rotating mass as possible seems almost to get to a scary level where it's like, yes, you can get them weight down on the spinning mass, but it gets to that scary level, like you're saying.
Yeah. Yeah, but again, it can be safe. So the good news is that we're seeing a lot more move towards increasing that safety, which is an important thing for the aftermarket and performance in general. Like you said, no, it's never a good day. You never want to see anybody having failures or of course, anybody getting hurt from those failures. So I think you're going to see, again, failures will still happen, but containment is the key.
Yeah, and unfortunately, when a failure does happen, it usually gets oily.
Well, you have, yes. You can have fires, obviously. So again, back to if you can contain that into the exhaust system and keep that where the oil can't spill out into a hot exhaust. Burning in the exhaust is okay, but when it gets all over the car and starts it on fire, that's again kind of back to, you don't want to have that happening if you can avoid it. So
it becomes a lot less fun. Yeah. What kind of racing do you kind of focus on now then?
Right now, obviously the market's still very, we'll call it drag racing in general, and even that really kind of comes down to just not just like even half mile, a quarter mile roll racing, right? These are all really kind of variants of drag racing, right? Yeah. So that's, I would say the primary market today. You have smaller markets in drifting and so forth, but generally speaking, say drifting isn't gonna push the turbo nearly as hard as you're gonna see in a drag racing application, because the rules are typically set by size of turbo, and that so turbo drag racing is primarily where we see racing happening.
Yeah, they don't have to quite push their stuff like a.
They don't have to push it to failure mode, because they just need to make a certain amount of power. So there's no restriction for a drift guy. He's like, what turbo size do I need to get the power I need to do my drifting with? So I'm not saying it's not demanding for the turbo. They do run them pretty hard, and they run anti-lag and things like that, which are hard on turbos. But generally, they can size their turbo with enough sizing that they don't have to run it to overspeed to get the performance they need for drifting.
But like once they have their car kind of dialed in, they're good. Like we have to, every pass a drag racer is like, I need a little up arrow, just a little bit more until you're kind of maxed out.
Yeah, till you're maxed out. So drag racing creates a very short, very, very hard application for the turbo, right? And for everything from anti-lag, like when you explode fuel and air in the exhaust system to spool the turbo, you're taking the thing and you're accelerating the shaft. Mm-hmm. It's not like putting your foot on it and then accelerating through the RPM. The speed is very slow. Here you're going 50,000 to 150,000 in a couple of tenths of a second max. Very hard on the turbo.
Yeah, my tuner generally hates fire coming out of the exhaust. He's not a fan of it,
There's probably a good reason for it.
Yeah, I get it.
Right.
It's cool every now and then, but he's not a fan of it. I'm like, come on, it's a little show. We got to have a little showmanship. But
you can. I mean, it's just a matter of the priority of what's the customer desire to have. Like you could shorten the lift for the turbo. Obviously, overheating turbines from two-step is also a very big problem where you can superheat the turbine blades very quickly with anti-lag. So application has to be. Yeah. There's no materials that can sustain just anti-lag continuously. It'll just disintegrate the wheel. So.
Well, now they're all pretty much billet wheels also, right?
On the compressor side.
For a long time, they were what, cast? They were.
Yeah, cast is traditionally had been how most wheels were made, but since the performance aftermarket is something, billet wheels have been happening since the mid 2000s. Yeah, and you get to billet machining just allows better design possibilities. Also,
even in some racing though, like it's like 100 pounds off if you got a cast wheel, like some weird things.
Because
like
you're giving up performance on the compressor arguably no one's really producing a performance compressor wheel, we'll say, cast today. There is technology that could do casting today that would have more advanced, but the tooling costs. So to have all this variation, which billet wheels give you a ton of variation, like you can make a few pieces of billet wheel. So machining is so inexpensive today relative to casting and tooling and so forth. So you can get similar performance in cast wheels, but billet just gives you so much flexibility in design.
Yeah. We've talked all about this turbo stuff. I don't know. I don't know if your expertise is more in turbos, I guess, or boost control of the turbo, or is it both?
I mean, today we spend more time and money on development of turbo than wastegate. I mean, we've done doing wastegate, for over 30 years. So there's still some minor improvements that can be made in application for a wastegate, but the wastegate at the end of the day, there's not a significant amount of technical changes that you could make to make it significantly operate differently, right? I mean, it's just there to control boost for your engine. So
mine just has to open all the way and then close all the way.
Yep, and so as long as you have the right size of the valve and the durability is there, where it doesn't lock up on you or something unusual happen for your wastegate. It's a matter of back to changing the size of the wastegate to appropriately work for the size of the turbo you're going to run. So it's really about sizing a wastegate versus is it significantly better operation than another design. So turbo, on the other hand, has tremendous development potentials, right? Especially when you go to application specific. It's literally unlimited number of things. So
yeah, we were talking about that, me and my buddy, the other day. It doesn't seem like there's been a lot, like in the last 10 years, like any massive change in turbos. And I don't know if that's incorrect or correct, but it seems like they've been.
I think the changes
similar.
that have been that we're seeing is that in kind of what we're doing with turbos today is a very big progression in operating range of the turbo. There's able to have a much broader operating compressor. So for performance or aftermarket performance, where it's not just drag racing, right? So you can create just drag racing application turbos, which are generally you wouldn't want to put on your street car because they're not going to work well for a street car. But they're going to work.
What would the difference look like there?
The main difference is you're going to have a massive turbine size on the drag racing turbo because you're going to run a compressor to a very inefficient area of the map, which is not even on the map typically, and then. Which means you need a lot of power. So the only way to create more power for running into a very inefficient compressor operating point is a big turbine. So now you put that on a street car, means that you're not going to get boost till very late in the engine RPM.
So huge exhaust side, very small.
Very, relative to the compressor, very large turbine relative to compressor.
Because like some of the 2J guys I know run like a 106/76, which is like pretty crazy stagger difference there.
And that's all driven by you need to get every ounce of air that they're going to try to get from that compressor. They need a turbine that big to be able to do it.
Yeah, and the front side is where they measure, and that's where the rules
that's the restriction, right? The restriction is that, but you're going to, if you look at any compressor map and you look at the last speed line on the compressor map, virtually every drag racer out there is running to the right of that high speed line. Okay. And it's going to be something like 50% compressor efficiency. So you're still getting more air, but you need a lot of power to make it get there.
Yeah. But it's interesting because like my car, it's a street car, but I don't need boost on the street. Like I could just, I putz it around the street, like it doesn't need to make 50.
Well, you have 3-liter engine, which is a relatively large engine displacement compared to say like a 1.6 or.
It's funny to hear you say that because I feel like it's relatively small in drag racing.
Just depends on the I guess class of racing, I suppose.
The cylinder head's so efficient, so it kind of makes up for it.
It's a great motor.
Yeah. It's not the Coyote guys, but
5 liters, 5.2 liters.
Yeah, they got all the displacement.
They got lots of displacement to work with.
But I don't need I could have a drag racing efficient turbo and still do everything I need to do when I street cruise it because
you can still your engine's. I mean, even without a turbo, the 3-liter. Engine's got enough torque to move a car around effectively at just normal commuting speeds.
It's a 3,000-pound car. It's not crazy.
3 liters, no problem, right? If you got gearing that lets you do that, then you're no problem there. But so you can use it. But I think the the broader sense is that if you have a smaller displacement engine, like the guys who are running 2-liter cars, 2.3-liter cars, right, that are running to 10,000 RPM, and you try to take that turbo and put it on a similar size motor, it's just going to be extremely. They're using 2-step to get it on boost. They're running a high RPM, not streetable turbo. So a true drag racing turbo isn't going to be that friendly for smaller displacement. Like I said, 3 liters, not super small, but 2-liter, 1.6 car, those really smaller classes is where you'd really see a problem.
They do get away with having a clutch, whereas I have a torque converter, so I have different. We have different problems.
Right,
they could get up on boost a little easier than I have to kind of fight through it.
Yep. Yeah. So shifting gears and things like that, you're going to be at lower engine speeds. It's not going to be as I guess streetable.
And they have to keep the turbo lit in between gears better than I do because.
Yeah, you're just using a torque converter and you're moving to the next gear. You're never coming out of power. Like you're on power the whole time. You never let off.
So how much do you actually have to, or not have to, but how much do you talk to the guys like kind of on the front line, I guess, that are using the product to get the feedback? Because I'd imagine it has to be some kind of feedback loop there.
We do. We obviously have customers that a lot of times we work very closely with to help develop a particular application for a turbocharger. So again, mostly these are, we'll call them performance applications where you're really kind of looking for more broad operating engine speed versus, again, back to drag racing, right? So drag racing is kind of its own animal, right? Like, I'm not saying, like you said, hey, I can use my drag turbo on the street. Yes, you can. Mm-hmm. Would you have a better tractable engine if you had a smaller turbo? Yes.
I have a one-track mind.
But that's okay. You get to choose what you want, right? Yeah. So it just depends on, it's really kind of customer driven, right, in that respect. But we do testing, obviously. And, today we do, we're looking at performance-based development mostly through computer simulation. Like, so if you take an existing application, you're trying to improve it, you can kind of do that mostly through computer simulation.
Sounds
today.
A lot more budget friendly.
Well, it is versus testing. Testing is very expensive and also difficult to attain all the data you're looking for, right? Mm-hmm. To get good development, you need a lot of data from the test vehicle or engine so that you know, hey, did we make that improvement or didn't we? A computer simulated world is much easier to go through multiple iterations, right, to get to an improvement. One, you have a baseline, and now I know how to make that better. And you can literally see that just through computer simulation versus needing to do extensive. In the end, you'll do a final, obviously, testing of that past CFD, but you can get a lot done through CFD analysis.
Yeah, because there's not all that many cars that make a really good back-to-back test mule because they have to be able to do the same pass 5 times in a row before you can change anything.
Too many variables.
There's so many on the track.
Too many variables to get good testing, right? So at the end of the day, that testing, it doesn't provide a lot of development part in the turbo itself, just because of the nature of, like you said, it's highly variable. Mm-hmm. Any day. What's the temperature, humidity today at the track? What's the, how did you do your lockup on your converter? There's so many potential things that change.
We're in Florida right now, so if you test at 9 a.m. Mm-hmm. and then you let the car cool down and test again at 11 a.m.,
it's going to be different.
It's 2 different, completely different deals.
Yeah, you have to try to nominalize that data, which is hard to do. Yeah.
And even a dyno is only so good, can only tell you so much, but you probably have an actual dyno for just the turbo.
That would be gas stand testing. So typically, no. We're today, fortunately, there's customers who have really good data acquisition on certain cars. We can do point metric confirmation of performance on car in points of that. So we're not testing the whole map turbo, but we can go, hey, we can collect data right off car and take that data and compare it to the simulated data without doing a full, we'll call test on the gas stand is what they call it. So
okay,
and so that's where we do a confirmation of performance, like you log turbo speed, compressor outlet. So you have to have a very well logged car.
Yeah.
To do this. So it's a Motec car everywhere with probably 30 sensors on it, right? To be able to get all the information, right? Well, they're the leader or have been a leader in that segment.
They have a lot of data.
There's a lot of guys. There's competition today for them, but they clearly were the leader in the market for a very long time. So, and they're still a leader, obviously. But having a good data log car and then being able to take points of operation and look at that data to confirm, your performance that you simulated is generally how we do it.
That is definitely a very complex thing to try to figure out on my end. Trying to understand it all is not a
yeah. It's again, back to cost analysis of, what's cost effective to develop a product with, right? And so at the end of the day, you can't, your customer can't, if we wanted to do to the same extent of, say, like an OEM turbocharger, where those guys they'll do significantly more testing, right? That they have to do for OEM requirement, but they're going to make, hundreds of thousands of the same thing for a particular car. In a performance turbo, you're only making hundreds to thousands max for that particular model of turbo. So you can't, the market's not going to bear, that level of development cost that an OE would have to do a turbo for a Corvette, let's say.
Yeah, that's a shame.
Yeah. So that's just the nature of that. But again, continuous simulation has really been able to allow us as a turbo manufacturer to be able to do a lot of development and get good results based on completely simulating it in computer.
So how, if you do come up with like a better way, you almost have to also balance how worth it is to implement across your line, even if it's just like 1%, 2% better, because that change is huge for a whole line of products.
It is. Like you kind of have to pick your points of where you can make a good improvement or not an improvement.
Like what's worth actually implementing for the customer.
Yeah, exactly.
Will they even notice?
Again, most of the
won't.
Performance notices, even in today, is still at the end of the day, right? The thing that people look at is, what was the 60 to 130 time? What was its quarter mile time? Because in customers will look at that performance metrics based on the users, right? Not that the data that we would publish for its capability isn't important. It is, in my opinion. But the end performance is really what people look at. And if people are having success in a particular segment with a particular application, they want that. Yeah. They're like, hey, I want to have that particular turbo because it's performing well for other people. That's kind of the bench of test, right? Like, are people being successful with that product or not?
Is it in the winner's circle?
Yeah. Is it winning? Is it going fast? Is it setting, a new time? Or that's what that's the market. That's how
is it
market
reliable? Is it going to
Well, they want it to be reliable.
20
Absolutely.
passes?
Right.
Because right now, you walk around PRI, there was more turbo companies than I've seen in a long time. I feel like a lot of different brands. There's a lot of brands. We'll say we'll call them new brands. I don't know how much those are really true engineering companies that create those designs or not. It's hard to tell. Like a new turbo or like a new label.
A new label is like, but are they doing the actual engineering design? So like for ourselves, we created the product 100%. We produced the product in house. I would say that a lot of those branded turbos are not produced. They're not produced in their own facility. We produce them in our facility in Michigan. I don't know. They don't tell you what they do, so I'm not going to assume anything. Yeah. But I'll assume since they probably would talk about it if they were producing it in their own building. Going, hey, we make this and design it and produce it here. They would talk about that.
I know you guys proudly put "Made in the USA" on pretty much everything I've seen.
It just kind of said, it's kind of a point of, who actually makes this product and who doesn't. And some people care about where the product is made, and some people, don't necessarily care about that. Mm-hmm. It really depends on the consumer.
The difficulty of making it in Michigan also sounds like a thing as well. Because is it nice? Is it hard? Is it because foundries in the U.S. isn't exactly a thing that I hear people not stress about.
Yeah, part of the reason we have a foundry is because foundry supply was always a difficult thing to get sourced and timely, good quality casting. So that moved us to do our own castings and be able to control our own supply.
Yeah, I've heard quite a few people that make parts say how difficult just the foundry part of it all is.
Yes.
And that seems like the stopping point for a lot of good products.
No doubt, finding a good supplier that can do casting. So, all of our products are essentially based on castings. Almost all of them are. In some respect, a turbocharger, you have castings for housings. Center bearing also. So having our own foundry allows us to control that design and deliverability of the product. And you can't. It's hard to do that, especially in the U.S. today. There's not that many foundries, and then most of those foundries are not going to produce automotive products. So they're going to produce something else, but not automotive products. So those castings have to come from somewhere else, right? And but again, it was back of need. Like, hey, us doing our own castings allowed us to control when we needed it and design.
Yeah, I'm sure that helped you through like 2019, 2020, and where.
I think there's no doubt there. If you were just buying castings, especially anywhere really, in the U.S. or elsewhere, supply chain was a significant problem for almost any manufacturer, especially in the U.S. It was really, really difficult. So if you were sourcing castings, you couldn't even get them in from, So if you have to wait and you say, hey, 6 months to get, you add 6 months to a lead time, are you going to, So
it hurt a lot of drag racers.
Yeah. They couldn't even get, things as fasteners. You couldn't even get fasteners.
Yeah.
Fastener guys were like, yeah, we're not going to have any material for 6 months.
Oh, man.
Yeah.
Well, even like that's a weird thing in itself because like ARP, those machines, I from what I understand that they use to make those bolts are like World War II era like machines that they don't just make anymore.
They're bolt headers, right? They had bolts, and the technology to do that's been around for a very long time. But if you don't have any material to put in that, how are you going to make bolts?
And quality material, it seems like
the quality is also important, especially when you're talking things like aerospace grade materials like 625, which is they make a lot of are the popular material for head bolts and connecting rod bolts today. Mm-hmm. If that's not good quality material, those bolts will fail. So you have to have a quality supplier of that material, and you can't just substitute with anybody. Like you can't just say I'm going to go resource this somewhere else. It's not easy to do, and be sure because you don't want to have thousands of rod bolts failing in the field, right? Like you can't just go I'm going to get it from somebody else.
Yeah, that doesn't really work for sure because once you source all those and they do start having failures, then what? Then you just sourced 10,000
Well, that's going to be
bolts.
really expensive because customers don't just fail a rod bolt, right? They fail a lot of other parts, right? Yeah. So it's not the rod itself that's failed. You probably ruined a crank, you ruined a block, you ruined a head, it's thousands of dollars of costs, right?
And most of the time, companies just say that's racing, and it does work, unfortunately, but it kind of allows them to get away with kind of whatever. If you can just say, well, that's performance application.
I don't think that. If you have material that's not good, and that's the failure mode, then that's not good. You don't want to be a manufacturer with material that's failing. If you have known failure, people will just move away from it and go to somebody else. So I don't think any manufacturer really wants to push any kind of poor quality material into the market because it could ruin their long-term share of the market.
For sure.
Yeah.
From your time in the auto industry that it gets shaken up like crazy with private equity is a big hot button these days with Doug Cook at Motion Raceworks is always attacking private equity firms and how they come in and buy companies and then bottom line needs to change constantly and products kind of suffer usually and end user really suffers.
Yeah, they typically aren't looking. They're looking for immediate return on their investment, right? So, in development of products, physical hard products take significant time frames, right? Like it's hard to bring design something and bring it to market in less than a year. Like it's pretty. By the time you go through development, design, and then tooling, if you're going to tool it and then produce that product, that's a year of time vested to get to a new thing.
Yeah, and you need to tell your shareholders every quarter.
And they don't want to hear that it's going to take a year or two to get a product to market. They're like, well, then we have to change something else. So I think I understand the movement of, a lot of the performance companies who are selling, their owners are trying to, get paid out for the years of time that they put in, right? Because
I understand that for sure.
Yeah, and I think that's those guys are looking for a return on their investment, right? So that's it. Kind of they don't kind of go together well, and so a lot of things change when private equity comes in and decides that they're going to do something.
Yeah, and because racing's like it's like a small group of people. It's not like this massive industry. It's a big industry, but like it's kind of like a clique of people at the same time. You know, it's not like
there's
OEM
a very I want to say it's very kind of segmented groups within the market, right? So the market's fairly sizable, but there's lots of groups, right? So they're kind of then you take that and you kind of break it into subgroups of everyone's got their own, like, I won't say niche, but it's a segment, right? And this is a segment, this is a segment, this is a segment of the performance aftermarket. So yeah, looking at what happens when or they get, you know, their directions change, right, from what they were offering for products when private equity, because they're going to look at it from a compare economic standpoint, because that's what they do. That's their only goal. Their only goal is to provide profit for the investor.
And as an investor, that's kind of what I want as their goal.
If you're an investor in that company, that's kind of what you want them to do. If you're on the receiving end of what they're providing, you're not necessarily a happy customer, because that they've taken what you used to be able to get, and they go, we're not doing that anymore. You can't get that any longer because they decided it wasn't worth. Maybe they only had a 10% margin on that, right? And they're like, well, we're not looking for 10% returns on that product. So you either got to charge more for the product, figure out how to reduce that cost, or eliminate it because it doesn't make money.
And also, like, supporting events is like a thing that most manufacturers do in this, but it may not actually be the return that they expect. Like, we don't actually get any return off supporting these events, but it's part of the whole ecosystem of racing is these companies support events and help the payouts. And
yeah, there's a social aspect to all of racing too, obviously, right? And again, that doesn't necessarily fit their typical model of what they're looking for in a traditional investment, right? They don't know how to it's hard to get a known quantity payback on that. Like, how does this social event pay back for us, right? And it's not always easy to track that.
Yeah, there's not really an exact direct monetary gain from some of these events that you can really just see on a spreadsheet, but there is actually a gain. They just have to kind of imagine it's there in a way, but it is there.
I think maybe in today's world, there's maybe a little bit better tools to try to track that return through social media. There's some tools available for marketing purposes that you can try to track a particular event, or that event generates some codes or things like that, so you can see what the engagement is.
Or like a person that you're trying to kind of invest in, because some companies just invest heavily in racers or events, or it's all kind of part of it.
There is, I think, a little bit better way to track it today. If you're really working on that aspect of your marketing and sales, that you can get some information back from that happening. Yeah, I think that's possible.
You're up in Michigan. How connected are you to some OEMs? Do you have any connection with them? Because now everybody's going, boosted.
Yeah, I mean, we do mostly through their motorsports team. So most of our interaction with most OEMs. So we don't produce any like OEM based products that go on to a showroom car, right? You go down to the dealer and buy a car. But we have done work with like almost all of the OEM manufacturers in the world in terms of turbocharged racing, or throughout Europe and through the US and through actually Asia also.
Like what kind of racing? Because you're not talking drag racing at that point, right? You're talking.
No, well, they're generally not. Most of the OEM racing isn't. Say turbocharged drag racing.
Yeah, it's usually
right?
like a blower.
It's going to be a blower or something to that effect, right? We're talking like mostly road racing, so endurance racing, road racing. So there, in the U.S. there was obviously road racing. It's a much lower level than say in Europe and in Asia. There's a lot more road racing going on there. So we've shown this on our social media too. So like the Toyota 24-hour Gazoo racing. So our product was on those cars for their wins, for wastegate. And so most OEMs throughout Europe, we've sold the product to all those. We have special racing versions of the wastegates for various, depends on what the OEM's needing for their cars.
I got to give a lot of respect to Toyota because they actually seem to really invest heavily in aftermarket racing. Whereas like even, drag racing, round racing, they're in NASCAR, like they're very well spread.
They're very motorsports oriented company.
I like to see that.
In all segments, really.
Which is nice to see from a kind of an enthusiast side of things. It's cool to see that Toyota invests so heavily in motorsports. I mean, they're top fuel teams and stuff. Like they spend their money in motorsports.
They certainly understand there's a segment for their business, right, is to be performing and leading in racing in all segments, really. So
I mean, right now there's probably a Toyota Camry going around Daytona,
right?
Because,
or at least there's I mean, they're pretty restricted on their rules. The cars are pretty much alike, I think, for all.
They're Camrys.
But Toyota is investing the money to go racing, and it's good to see. I mean, it helps the industry in general, right? When you see OEMs investing in racing, and people get excited about racing and want to go do it.
And I think they're Gazoo Racing. Is how you say it, right?
I think that's correct.
I don't know how to say that either.
If I misspoke that, I apologize.
I've seen it on like the new Supra. I guess they have like a Gazoo edition and stuff, and then they have the Yaris and stuff. They have kind of a few different packages. I don't know where that comes from, but.
Again, back to their racing team, right? They have they develop parts for their race teams. I think they do a lot of that. Toyota's funding it, but they do the actual cars. So I think that's where these extra performance, why they're being offered actually on the car in the showroom, right? You can go get a version of that car.
So you're talking Europe. How big of a market do you have over there with performance stuff?
I mean, it's good. I mean, Europe in general is a good sized market. Because there's a lot of countries there that like motorsports, and racing. So it's a good market. It's not. I mean, obviously, U.S. is the largest, but I would say it's kind of market is split with Europe and Asia at that point in terms of where we sell products. So obviously, U.S. market's still the biggest, but then when you add, the other two segments, it's good chunk of the market. So everything from turbochargers stuff to wastegate and blow-off valve. Yeah.
I've been seeing a lot more videos of Thailand racing and that kind of Asia because they love modified cars over there, which is cool. And everything they have is turbo. They don't have really V8s like we do.
Yeah. Same thing in Europe too, right? Most cars are turbocharged or vehicles in general because, again, back to fuel prices, generally speaking, fuel's probably very expensive overseas for a long time. Yeah. And that forced turbocharging, right? So you have a small engine, but you can make a lot of power with turbos. So that kind of made those markets. And U.S. is kind of an unusual market, right? Because we have large engines in production, and they get used for insanely powerful engines, right? To go drag racing with. So that's great.
Yeah, we kind of got spoiled a little bit on that deal. We kind of got the best of everything.
Yeah, we got the whole range, right? And it's nice to see the market is diverse, right? So you got everything from imported cars that are small displacement racing and all the way up to large V8 stuff. So it's a diverse market.
Yeah, and then in Europe, like I was saying, the diesel stuff, obviously they all need turbos, sometimes two of them. But that probably helps a lot with their... It's funny to see the diesel racing in.
There is I don't know that we specifically, we've done a few things with some diesel applications for racing, but it seems to be, it's an interesting market, right? And we see it here in the U.S. It's still back to drag racing and tractor pulling, right? I mean, it's kind of like a very segmented off chunk of the performance market here in the U.S. For performance turbocharger or wastegates or any of those items to go on diesels. In Europe, I don't think you see that so much on the street cars. I think it's still mostly gasoline. There is diesel performance, but it's done usually with a hybrid turbo or something on
I guess a lot of them too don't run wastegates or blow-off valves sometimes.
There are some. It's not as prevalent, right? Variable
they should,
nozzle.
But they often don't. They just overspin their turbo.
I mean, if they know what they're doing, wastegated applications for diesel make sense, obviously, but there's a lot of VGT applications out there too. A lot of times they'll say, "Hey, it's just maximum boost. We're just trying to run all the boost because we don't need to wastegate it." And if you're drag racing or tractor pulling, maybe that's the case. You just make maximum power. No worry about.
You just live with the compressor surge.
If I can make 100 psi, that's what I need, man.
Man, that's a funny one too. Is people I get it all the time. People come up to me at the track. They're like, "How much boost you running?" And they just want to hear a big number. Meanwhile, it doesn't actually correlate that closely to things.
I mean, it's interesting that that it's just about a boost number. Would it be more about a power number? I think, but
exactly.
Just making boost doesn't necessarily mean you're making power. It's not. They're not exclusively the same thing. But
I always give them the number. I'm always like, "Oh, it's 70 pounds of boost on that pass," because they love to hear that.
Right.
But then you go ask the V8 guy, and he's got 500 cubic inch, and they're like, "How much boost?" And he's like, "Oh, 14." And they're like,
"Yeah,
he's making 3,000 horsepower."
Yeah, exactly. So But diesel engines obviously run a lot of boost compared to like most non diesel engines. So
because I guess they're not small displacement. They're just weird. They're just kind of an oddball, I guess. But the boost number is funny because, I mean, even like as a turbo guy, you probably talk more about flow of a turbo, like CFM, than you would care about the actual boost number depending on the
I mean, again, we kind of look at the application again for what we see in our turbo segment. We're still, again, back to twin. So the size turbos that we currently are producing, or now have grown. And it's still where we're going to have some larger frame applications coming out this year. They haven't been launched yet, but they're coming soon. But the small frame, we'll call it, which is based on a GT, what people will call a GT35 frame size or physical size, right? Which is most people are familiar with, is that, we've, again, revamped that line. We just introduced new aero for that. And now we have customers producing in what used to be a 600 horsepower size, physical size, right now are producing 1250 or 1300 horsepower in that size turbo. So that's new, and no one else really has that in terms of that physical size. So one of our focuses has always been maximum flow rate within a package size, like how much airflow. And most of our development's been on the smaller frame turbos, but again, most of the engines that are using them are smaller displacement. And we'll say 1.5 liter engines up to. I mean, we have to do some side by side stuff now. Current turbos currently hold the record in side by side, drag racing again.
Oh, but it's very cool.
Yeah. So. And about to introduce another turbo in that segment of the market. So our focus has been on smaller displacement stuff. But you put two of them on that now, and you're talking almost 2,500 to 3,000 horsepower on a twin turbo application.
So I assume you're talking like a Can-Am X3 probably. Yeah. Those things love boost. Those 3-cylinder, and then the CVT deal that they have is actually pretty efficient.
Yeah. So we're going to release another turbo here shortly for that segment. And
what do they race? 330 normally?
I don't know the exact distance on what the actual length of the. I'm not sure what it is.
They make healthy horsepower though, too, though.
Well, they're making significant power.
Yeah, like those things are. It's growing pretty fast, that segment of motorsports, because those things are so readily available side by sides.
For the money. So if you look at cars, right, versus say side by sides, right, the amount of money to go experience that level of performance, right? You're talking a magnitude more cost than car, typically speaking. They're just more money, right? And now you can go do this in a side by side and experience that performance. It's more. When I say cost driven, one, there's no restriction. You're off road on some sand course, right? That you go do this on, right? So there's no. It continues to grow as a market, and I think it's a more affordable cost of doing motorsport for a lot of people, and still get that great experience of that performance.
Yeah, I think people don't realize just how good side by side can be, and especially the amount of use you can get out of it, and the simplicity is so nice compared to a car.
Yes,
because like
it's easy to work on. That's right. Everything's easy to get to and work on.
You don't have to take anything apart to put a turbo on. It's right there.
So you can certainly see the appeal of side by side, performance vehicle and. Also, like I said, the overall cost, right, for any metric of performance, like how fast does the thing accelerate, which is what you experience in drag racing, right? It's just like you can get that for a much lower cost.
Yeah, I've been to Silver Lake up in Michigan, so I understand like that whole environment as well, and it's pretty awesome up there. It's pretty.
It is. It's a cool spot. Yeah.
The side by side world is definitely booming. I'm pretty excited to see few years of that growth. But they have become exceptionally complex and insane machines. Now they're all like 5-lug, big axles. Like it used to be like they broke all the time. Now they're like these.
Well, again, the performance aftermarket grab a hold of that and just say we need high travel suspensions. We need all these things. And so the market jumps in and goes, experienced guys who are producing parts for cars were like, well, we can produce parts for side by sides too. And it's a growing market, and it's good to see.
Yeah, I mean, even Motex are on there and stuff, and
the whole segment, and again, affordability, right? Motorsports at a more affordable price. So,
and then the other flip side of that is off-road is nice because you kind of get to snake by the EPA a little bit differently.
I mean, I think you still you don't have to
off-road application.
I think that they still have there's some stuff on there, which is like EVAP and some other stuff that are still on those vehicles. So I don't think it's 100% pass there, but it's generally there's a lot less restriction, I think, and it allows you to do more performance work.
Yeah, because that's the other hot deal in our segment is EPA infringement on.
Yeah, I think that the nice thing about today's market is that there is technology. The technology can allow performance products to be road legal, and SEMA is working really hard on providing a path for manufacturers to be able to get their products certified for applications, so that they're not having to try to skirt any kind of rule or anything like that for cars that are going to be driven on the street. So it's and they've opened. They recently opened a SEMA garage in Detroit. They have a emissions dyno there, so guys can provide a better path now for guys. Because just because you have a part for the car doesn't necessarily means it's going to not pass emissions. It's not necessarily the case. In fact, a lot of these products can pass emissions. It's just that where do you get that source? Right, it's back to source of how do I get this resource to certify my product, and SEMA is a great, works really hard to work with the group of SEMA to get cars, so that guys can actually develop products for cars and get them on the street and not be violating any regulations.
My worry is whenever I hear still like smog legal, I usually just assume it doesn't actually make much more power or it doesn't actually help performance, because I would assume it would put out more emissions if it was actually adding performance to the car.
Actually, no, it doesn't. I know that would be the perception. I think traditionally that would be the perception. Like the only way to make more performance is to not have it meet emissions. But that might have been maybe more the case back in the early development of emissions controls for vehicles, or in the infancy of every car is going to have a emissions control device on it, right? Catalytic converters and other types of things to keep emissions down. Today, because of 30 years now of technology development, from catalytic converters to all the things you need to make a car be certified, best example is like, say, what Holley does, right? So today's Holley, they're able to take in a car and with changing no emissions on it, tune it, and still pass emissions, and certify a car. So people shouldn't necessarily be scared away from an emissions compliant performance idea, right? That it can't make power and also not violate any regulations at the same time. Yeah. So and that's continuing to grow. So the good news for the performance aftermarket is there is a way to do these performance things and still not have that problem.
I guess that I've always just worried it's a revolving thing that you're trying to like catch almost. The changes in emissions laws and the rules?
Not necessarily. I mean, yes, emissions always are progressing, right? Like so they're always changing to try to improve whatever those emission standards are to try to make things cleaner. But the rules are such that it's each model year, if you're developing something for, let's say, 2006 model car, it has to comply to 2006 Model 6 standards for that car. So. So the newer the car, also the OEMs are much better at getting a lot of performance out of the car. I mean, look what you can go down to the showroom today and buy, right, from a performance envelope versus 2006. But if you did develop something for a 2006 car, you're really only required to basically make 2006 emission standards, whatever those were for the time. So
that's funny because I said that one time on one of these podcasts. I was like, these new cars are so good, you don't really have to do much to them to enjoy them. Whereas like if you have a 96 Camaro, you have to do a lot to really like it. But now you can buy a new, I have a 2012 CTSV. It's so good with basically nothing.
Amazing performance. And even so,
it fulfills all my street
tuner
needs.
Guys can go extract even more power from that and still make it comply. So the good news is that as technology evolves, that performance cars still can get better without having these issues. And I think hopefully a lot of guys are getting a hold of their SEMA guys, because they are there to help small manufacturers figure out how to get their products on cars and not have any issues with not complying.
I will say it's in my nature to be non-compliant. It's just kind of how I'm wired.
I think the industry is. I think it's changing though. I think that it's changing a little bit. Like I think
it's forced to be changed though. I don't think a lot of these guys are choosing to change as much as there's quite a few lawsuits that force change.
I mean, again, there's rules in there, right? And you don't want to be necessarily in that manufacturers don't want to be in that group, obviously.
No.
And so again, manufacturers are looking at ways to provide, products that are fully developed and are compliant. And the good news again is that they can be compliant and still produce great performance and have an enjoyable experience for the guy who's in performance.
Are the people that are writing this stuff, though, do you think that they're qualified to be writing it? Like the ones that are writing the emissions rules and regulations, are they really as qualified as, say, somebody like in a aftermarket or like somebody in your position that may be like, well, yeah, but you can't really do that. Like, that's not really reasonable. Like, or is it just they don't care? Like, this is the baseline?
I think their approach really comes from, a completely different direction, clearly, which is it's not a consideration of any particular market specifically. It's not, EPA is not making their rules regulations based on racing, let's say, for instance, or performance in general. They're just like, we think that we need to improve emissions because there's still too much smog in the air and in the environment, or there's too much particulate, or there's too much, and trying to create, I think that's where their general approach is. And now how they write those rules and regulations are, could they be better? I think they could consider more potentially, right? But, would require a cooperation of, that's not adversarial, right, between the groups, right, where you could actually sit down and have a conversation that would say, hey, we don't want to be non-compliant, but if we changed it and did this, we wouldn't have to be non-compliant, and we can still achieve our goals. But I don't think that channel is typically open.
You're much more conversation. Reasonable. You're much more reasonable than me, I guess. So I think kind of on the non-compliance level completely, and you definitely think. But I don't own a manufacturing facility. So
the problem is that you have two people that don't have an open. There's not a communication that happens between the two groups that could be work together, kind of an attitude or mentality that we can arrive at a solution that works for both parties. And
that's what I worry. It's written by people that don't have any real knowledge of what people would have to go through to make things compliant.
Yeah. No, I don't think that's their consider. I don't think that they necessarily consider that. That's not their.
Which I don't think their
primary. It is unfortunate, but again, it's back to government and having. Hopefully your representation at government making that connection, right? So the guys that you elect to Congress or whatever should be opening that door to those departments to go, like, we need to, look at our whole country and go, hey, we need to have communication between the government. So it's not so it isn't always adversarial conditions that they have to operate under. They shouldn't have to do that, but it requires cooperation. At the government level.
Well, like we had the RPM Act, which
I know, which it didn't. It still didn't.
In the water.
It's unfortunate. It should have passed. It didn't mean that there was going to be a whole bunch more non-compliant vehicles. It didn't. If you read all of the information they put down, it was basically going. Almost every race car is based on an OEM car, right? This is how racing exists. But to say that you can never take a car and make it. That's their position, right? So it's back to regulation versus, we'll say, law. There's been ability to write regulatory stuff, and this is where they could have stepped in and actually done something positive for the industry, and they try to, right? But they get tied up with a whole bunch of other stuff, and then they never get back to it.
That's what kind of hurt me when the EPA came out and they were like, no, we love NASCAR. I'm like, yeah, but what does that do for me? Like, because like I was like, I have.
Well, see, NASCARs aren't.
They don't have VIN numbers.
They don't have VIN numbers, right?
I have a VIN number car because I'm not building a tube chassis car. Like
right.
And even then, like, people aren't going to build parts if you can only sell parts to people that have tube chassis race cars.
And the thing is that they should be allowed to. You should be able to take, again, if you're not operating on roads, so forth, to take the cars and enter sanctioned racing events with the cars that are no longer. And I think that was the point that we're trying to make. It's like, to say you can never have this car. It's no longer in road use, right? So let's be allowed to reclassify a car, right, to non-road use, and then go. So you can go race the car and then do what you want, and then you comply with like all the OEMs create non-compliant racing. Well, I shouldn't say that. Some of them do, but
they sell body in white, where you can kind of just no VIN number.
But you can have they produce non-VIN numbered race vehicles, right? And they don't fall under obviously those regulatory problems, right? So why you can't say, hey, I'm officially filling out paperwork that says I'm going to remove this car from our use. It's only going to be used
Take the
for
VIN
sanctioned
number.
Racing events. I'm going to remove the VIN number from the vehicle. It can no longer be registered for the street. I mean, these things seem very common sense, right? To be able to have that option to do. It's unfortunate they just couldn't get it through, I mean,
and it's hilarious too, because like my race car, it has had no engine in it for 6 months. Like it's on E85. It drives very little, basically none. Like, like it burns maybe.
Well, that was the other point they were trying to make. If you
gallons.
take all of the motorsport things that are going on and you compare it to total level of all emissions, right? It's an amazingly small amount of actual emissions. So that would be the other point. It's not like it's going to be contributing significantly to any other issue that's going on. So it made sense, common sense and logical to do it. But again, cooperation among people at the lawmaking level, they just can't get past.
I haven't heard what PRI and SEMA's next step is, though, because the RPM Act is kind of stalemated.
I think it's probably it really is because there's so many other things going. I think there'll be maybe another opportunity for it to be looked at again in the near future, possibly, and it can come through. So you just you yell that hope that they'll do that for it.
I imagine you're part of obviously the SEMA and all that.
Yes.
So
I've been
probably well connected.
I was a SEMA mentor from 1993. So I've been part of that, gone to SEMA, displayed at SEMA and PRI and so again, that's kind of why, let people know that the resource of SEMA and the ability to, people want to be able to have that ability to do performance work and you don't, utilizing those resources are important for manufacturers and it provides a cost-effective way for them to actually get their products
Well, it seemed like it had a lot of momentum, and then when it didn't, that's when Jamie Meyer left. I think he was like, it's not working out, or he went to a different opportunity again. I knew him when he was at Chevy. Well, we knew each other a little bit, but and then he was with PRI, and then that kind of didn't.
Yeah, I don't think it's I don't know that it's really a dead. I think it could be revisited again. I think it's just has to be reduced and get somebody to. It's happened a couple times, but what we've seen happen in government over the last 3 or 4 years has been. It unfortunately doesn't get a priority, right? Yeah. I think it's not that it couldn't pass. I think it's that unfortunately there's so much other stuff clogging up our system for them to actually take the time and get it through. So maybe, again, hopefully there's another opportunity in the future.
Well, when I talked to my congressman, they point blank told me, well, we have a lot of things going on at the moment. I was like, that's always tough thing to say to the person that's like, that's a tough thing to say to somebody who comes to their congressman with a problem, to be like, we have too much going on. You're going to have to wait until it's too, like, when is it my turn?
Yeah, I would agree.
I agree with those other problems, but like you can multitask, right? You can do two things at once.
It would be nice if they did it, we're able to get to more work, right? But, They don't seem to get to it. I don't know why it'll change or not.
I know, we tried. Well, we can switch up from that. I know that's it's just a hot button lately in the last few years of all of this. So it's kind of been something that I've talked to.
Yeah.
I try to talk to a lot of different people about it to get different opinions. And your opinion is obviously a lot different than the typical drag racer that has no affiliation with SEMA, PRI, and manufacturing in general.
Yeah, I mean they're an enthusiast who's going out, or they want to go out and do racing, right? And those things are kind of don't comply, right? I mean they're not in line with each other, right? So it would be nice to have those things where they're in line with each other, and it hasn't happened. But for manufacturers, I think it's their goal is to produce products that can be used and used without having issues with regulatory problems.
Yeah, I feel that. So to change it up, is the Porsche 911 Turbo S still the best car on the market?
It's a great car, right? I guess
every time I'm in one of those, I'm just like, this is so much better than everything else.
Obviously Porsche makes great cars and great sports cars, right? So is it the best? I mean, depending on what metric you want to, from an
all for the buck, I guess.
I think all around performance envelope, right? It's a pretty darn good car, right? It would be, yes, are there some hypercars that are that are faster and will go around the Nürburgring faster and all these other metrics that people use for performance. There's a few hypercars, but it's kind of the upper end of the sports car scale that gives you kind of a user-friendly, like you drive around the street, it's a grocery getter. Literally, you can go get groceries in the car.
Well, yeah, my buddy has one and his pregnant wife drives it.
Right.
It's like her car.
And it's no problem.
And then he goes and runs spectator drags in it and wins. So it's kind of like this crazy balance.
So it's a great car. I'm trying to think of anything else that has maybe the performance envelope. There's other good cars out there, but it's a pretty amazing car.
Did you see Porsche sold recently, like a massive percentage?
So what VW owned the Porsche, since 2009 or something like that. I think is when they ended up taking over Porsche from at the time, and then they just recently spun them off as a separate company. So now Porsche is its own automotive company, separate now.
It seemed like it was because Volkswagen needed some money real quick to pay their fines, I think.
I think in general, they needed to raise money. Porsche is a very profitable company. Mm-hmm. Obviously, they're
worries me for the future of Porsche, I guess.
Oh, I wouldn't worry about it. I think that they still have plenty of resources to go do their. Porsche had a lot of their stuff was their stuff anyway, like a lot of the development. If anything, maybe VW could suffer more from non-Porsche development, maybe in terms of their market. I think
to EPA connection again is they had to sell it to pay some of their fine from the Dieselgate.
There was definitely some bad decision making over at the VW guys. The Dieselgate some of the internal management probably didn't make some good decisions there, and definitely cost them significant monies, both from a cost of. That was a big cost to them, obviously. And I think they saw an opportunity. Again, Porsche was very good company and could spin them off and generate cash that they needed, probably, is their decision process there. So they could stay and reinvest. Like you said, they constantly have to evolve, right? It's the automotive market's very competitive, right? So how do you maintain your sales segment in the cars if you don't constantly develop? Because everyone is.
And I think they're obviously putting a huge amount of money into EV development and hydrogen, I think, which I don't know. Hydrogen's always felt like a dead end to me. I know everybody loves it, but it's always felt like a little bit of like a non-starter.
Well, it approached from a different, like pure hydrogen cars are unless you're going to do probably fuel cell type of vehicle, that's probably not the best approach to hydrogen. There's a different approach where you would use a different liquid fuel carrier at room temperature versus hydrogen, which is very difficult to store, liquefy. All those things make it very difficult. But if you were to actually use a different carrier like methanol would probably be the one of choice, just because it carries more hydrogen than. So if you have a liquid gallon of methanol and you have a liquid gallon of hydrogen, methanol carries more hydrogen per gallon than pure hydrogen liquefied.
I don't know if I would want all these street cars running around on methanol or have methanol.
It's a great
in
feeling.
them.
Are you kidding me? Great.
It's so flammable.
So is gasoline.
I guess so.
Gasoline's just
methanol is just scary because like anytime.
Methanol would be. If you could get the fuel system, you'd have.
I like methanol
way better
for a
engines.
race car.
You'd have way better engines. Everything could run around on 12-to-1 compression ratio, right? And still be emissions compliant and all those things. Absolutely. Methanol would be great.
But ethanol never even took off, and that kind of is a bummer.
It's how how is ethanol produced, right? So you're producing it from biosources, typically speaking, versus methanols can be produced from biosources also, but obviously produced from petroleum or natural gas. There's other things you can do. Ethanol could be, but they focused on the biomass version of that for ethanol. Ethanol can be produced in other ways also.
I've always all my ethanol is corn based.
But methanol from a hydrogen standpoint. So if you could adopt if they would change to methanol, everyone would be super happy.
Really?
Oh yeah.
And
best performance fuel on them, period.
Less carbon monoxide emissions.
Yeah, easy. It's a simple molecule. If you look at that compared to gasoline, it would be way easier to make a methanol versus a car compliant than it would be gasoline.
I've never heard anybody say methanol is, I guess, the right route. I've just never heard that.
Actually, if you look at
I don't understand.
If you look in history and time, there have been segments that methanol was the primary fuel back in history. It's a great fuel. They should have, but again, back to how is it produced, and it's wood alcohol. So it was produced originally as from wood. as sources for fuel for vehicles, especially when there was scarcity of petroleum products during wartime and so forth.
Okay.
But then the petroleum guys, that's a huge business, right? So they control that energy market, right? So that's why methanol isn't the primary. They seem to have this pesky thing called gasoline come off of oil refining that they wanted to sell.
It all comes back to mobile. It all comes back to mobile.
I mean, gasoline was a byproduct of making kerosene.
Yeah.
So it is a useful fuel. So don't get me wrong. It's just that, is it the best fuel? No, it's not the best fuel.
Well, the town I grew up in,
plentiful.
The town I grew up in, it was whalers. So they got destroyed. Right. No more whaling all of a sudden.
No more whale oil, right? And so kerosene came along and pushed whale oil out of its existence. But this is how the market evolves, right? But again, methanol, if you're going to move to a hydrogen economy or hydrogen transportation fuel, you already have infrastructure for liquid fuels, right? You just have to substitute what that liquid fuel is, methanol. And you can produce it just as easily as you can produce gasoline.
Would it just be one grade across the board? No different grades?
There's no such thing as a grade.
Yeah,
it's methanol. Huh. There's no additives. There's no, gasoline has to produce all these additives to get it to burn cleanly, right?
So but how different of methanol would it be from what we use in a race car? Same thing?
Nothing. It's methanol is a molecule, right? It's a single molecule. Gasoline is complex hydrocarbon, right? That requires other liquid additives to get it to burn cleanly in an engine, right? So this is why it's they call a blended gasoline, right? There's all kinds of things they add to gasoline to be able to make it so you can be emissions compliant. Methanol doesn't require that. It doesn't require any additives. It's methanol. You can just use it as is.
So the future is in methanol, and
from all aspects, if you think about it, you could run methanol in your car. You can run methanol as it is with an internal combustion engine, and you can also use it in a fuel cell. So with a catalyst and a very simple catalyst in small temperature change, you can break the hydrogen off methanol very cleanly, and you can transport the fuel anywhere. So infrastructure is already set up. Methanol.
Well, everything in an engine would be very happy and clean.
Absolutely, best fuel.
Yeah,
hands down. Best fuel.
I mean, everything would run cooler. I've just never heard it. I guess I always just assume methanol is expensive. But it's just because it's
only really kind of expensive, really only due to the fact that it's produced in not the volumes that you see petroleum for gasoline, right? So this whole refining of, as you're refining oil into diesel, right? There's this other stream of all these other light hydrocarbons that come off, right? And one of them being gasoline. So there's a plentiful amount of gasoline that's literally a byproduct of refining oil, down to productive kerosene for jet fuel to diesel. And diesel, that's the primary, you produce that. All these other streams are subsequent to that.
So if it was mostly methanol, would that be produced from organic product?
No, you can produce it from natural gas. You can produce methanol from natural gas very easily.
So then why would the gasoline companies be opposed to this if they can still make it?
Well, they're still producing a lot of diesel, so what do they do with the gasoline? So they could probably reform gasoline and probably refine actual gasoline product down into a simpler product like methanol. They just haven't invested any money in doing it.
I wonder how that would work in like an aerospace, because they already use basically diesel, right? It's kerosene pretty much.
Yeah, Jet A1 is like kerosene.
Yeah.
So, but you could run other liquid fuels in turbine engines. So it's density, right? It's the energy density, and jet fuel is one of the reasons that they want to use it, because the amount of energy they can get, it's very densely, where methanol per gallon total energy is less, right? So you don't get the energy density that you get in kerosene.
Do you think methanol would need a rebranding? Maybe change the name a little bit? Maybe try to get something a little bit more fun?
How's methanol not fun?
I don't know.
Is there a stigma to methanol?
I don't know. Maybe there is a stigma in my brain, but maybe I would have to ask like somebody that doesn't know. Like, hey, right now you buy gasoline, fossil fuels. People love hearing that. Oh, this was a dinosaur, fossil. Like,
you can produce most fuels from other sources.
Yeah.
Like, again, petroleum is still, it controls the market today and will for a foreseeable future. To produce other fuels. So if you want to have a clean fuel, like methanol would be the best one, because it's so diverse. Like, you can put it in your internal combustion engine. You can put it in a fuel cell car or trucking, for instance. So again, back to efficiencies, and it would be the right path. for hydrogen. So if you want to have hydrogen, you do it through methanol, because all the other infrastructure is in place to be able to handle that liquid fuel, where you don't have that for all the other options.
Well, then there's even very, very few cars that I've seen run on LP, which is like a very rare thing, but I've seen it in like the Midwest.
Because it's back to availability of fueling, right? It's still not the easiest fueling. It's pressurized, right? So you have pressurized tanks. Methanol don't require pressurized tanks. They don't require, so again, it's kind of like you boil it down to the most common denominator of the reason that liquefied natural gas is only used in certain applications where, like buses and so forth, it makes sense, right? Because they come back and go to the same spot all the time. So you can fuel them up on location. They're very clean, burning. So same thing would be true if you were running methanol, right? In these types of applications. It's just that you would need to switch your production to be methanol production versus gasoline.
I'm sure the freaking hypercar companies and supercar companies would love if everybody switched to methanol all of a sudden.
That's what I was saying. If you could get, common sense doesn't always rule the day, because there's people who have money invested in not that thing, right? Mm-hmm. So where the money is invested is not in methanol at the moment. There's a good investment in it already. I mean, there's a methanol infrastructure there, but it's not the magnitude of what you see for diesel and gasoline product, right? So you would need to make a change, but that's only going to happen through regulatory type of stuff where you're going to force a change to happen, because why reinvest in another type, in that when you were
able to get away from leaded gasoline? That was a good one. Mm-hmm. That was a good.
But they could have just said, hey, we're just going to produce methanol instead.
Yeah.
Right.
I just wonder, who needs to know, I guess, really to start implementing changes? Because I guess people the VPs of these big gas companies probably know that this stuff, or they just have no idea, and some engineer knows, but he's just kind of doing his job. And
I mean, I think VP's got an interesting, business. They make lots of different fuels, right? But they have ability to control or force the market to change, right? And that's no. I mean, only people who could force change would be really large corporate entities. If they decide they wanted to make that change, they won't. I mean, they're not going to do it just because. Mm-hmm. They have to have what do you want to say, financial reason for doing so, right?
Yeah.
Or government's going to say, this is the thing we're going to switch to. So
that's crazy too, because if you think about it, the same engine would just make more power, run more efficiently.
Yeah.
And it would.
And you wouldn't necessarily have to get rid of the lowest cost, way to power transportation.
Well, now I'm kind of frustrated.
So not that I wish our conversation had an influence, but no, I mean that's an interesting one. Methanol, but yeah, methanol would be awesome.
I'm glad we got to this talking point, because I had no idea. I mean,
it's one of those things that people don't necessarily know. I mean, the information's out there. It's actually easy to find if you take the time to go look at that particular segment and why it would make so much sense. But the money's not vested there yet. That's the thing. So once you can get people on board to invest the money, it is the most economical solution in the short term. If you want to make a change to, we'll say cleaner fuels, and methanol would be it gives you all the options. It's transportable, room temperature.
People would like it too. Like if you look at how clear it is. It's like water.
And again, if you wanted to go to where you have a zero emissions point, like for cars or even trucks, is that you can use it in a fuel cell and produce literally just water. Like there's no emissions penalty for using methanol in a fuel cell system.
The byproduct would just be water. That would come out the
water and CO2. But that's always going to be the case. You're always going to have But the source requires it, right? It still could be closed loop depending how you produce that fuel. Yeah.
It just doesn't make sense too, because the OEMs like Ford, where they're like fighting, and like Dodge that are fighting to have these big engines, could push this change a lot, because they could still have their big engine, but then they could also kind of force the change that allows the big engine, and they could still have their marketing of the big engine and make more horsepower. Mm-hmm. So that, a freaking supercharged Hellcat would love methanol from the pump.
Agreed. I agree. It would be a game changer if they they look at that at a level that makes sense, which is the economic sense of it boiling down. But again, back to people always have their angle, right? And the angle is whose money's invested where, right? So the amount of investment you see in the existing infrastructure means anytime, it doesn't matter what you want to make a change into, right? Whether it be electric or anything else, the cost to change is very high, right? And they're all vested and they want to get all their money out of their investment. So,
well, I mean, we saw with E85, you know, like there was a boom and then a bust. Everybody had flex fuel sensors for a long time, and then it kind of busted. I talked to Jay from Ignite Racing a lot. You know, he's a close friend of mine, and he was part of the initial boom.
Right.
And he kept trying to fuel that fire, and then like it just seems like it's not going the way it should in a way.
Well, I think that again, back to it's how you do the sourcing, right? And I think that it wasn't necessarily the best way to produce ethanol necessarily, like the how they decided to go. It is not a. There's more energy input than it's not a zero carbon deal when you look at all of the costs involved in producing ethanol. And the studies have been done. Again, the studies are out there. You can see that it actually you're still putting a positive CO2 footprint out there that they're trying to eliminate, right? And so I think that's part of it. Cost, it's subsidized, right? It's also subsidized for all the agriculture to produce all this corn, let's say, to produce ethanol. So it's very complex, not single faceted thing. Again, back to cooperation and what's the most logical decision making process. Doesn't seem to happen. So.
Yeah, I mean, I definitely get that.
If you could boil it down to common sense and logic, it would really be easy to make a decision.
I was even, while you were saying that, I was thinking like nuclear power is how it's such a taboo thing. People are so scared of.
For no good reason either.
I know. I mean, we had one where I grew up on Long Island, and before it even opened, it was protests to shut down.
Yeah.
And they never even opened it. Like I don't know if they ended up opening it, but they were fighting it and fighting it and fighting it. And 3 Mile Island,
it's a misconception of nuclear energy. Again, back to people understanding, and you have a group that don't want to do nuclear, right? And they say it's bad, and it's like, but it is a great solution for a lot of the things they're talking about. One, for low cost energy, right? You want a low cost energy economy. That makes a great economy. Yeah. High cost energy does not make a great economy. So you can't grow an economy with high energy costs. It's hard to do.
Energy is pretty much the only fuel for the economy in a way.
It is. Well, it's the root of if it became
zero, if it became zero, the economy would be completely different.
There is no economy without energy, right? You have to have energy from some source. It doesn't matter what one you pick. You got to have it, right? There is no economy without energy. But again, decisions are not made logically necessarily, and they could be, but if you wanted to use logic, it would be much easier. Like, here, I have my math problem. My math problem is better than your math problem. It's lower cost right here. So why don't we do this, right?
I know, and then they're like,
because that should be the winner, right? It should be a clear winner. It's a mathematics problem. It's easy to solve, and the math says do this, but.
On my wall, there's a piece of a nuclear reactor, actually. There's a little sliver of one, and it's a used one, and it's perfectly fine, and it's perfectly safe.
But nuclear power, I mean, today, it's just like saying that there's been no technology improvement. Yes, I know they're angling towards fusion. Maybe someday that becomes a reality, but there's a period that you could use today with nuclear energy that would solve a lot of problems, actually, which would, just... breeder reactor nuclear is the solution. You can get rid of 95% of all nuclear waste in a breeder reactor. So, but they don't go do that. Right? Again, common sense doesn't rule the day. Common sense doesn't rule the day.
Well, what scares me is how long they take to become operational and how little are being built.
Well, unfortunately, we back then there was a decision process to make what type of nuclear power should we use. They decided to use a light water reactor instead of a breeder reactor. So if they'd invested the money in breeder reactors, we wouldn't even be talking about things like 3 Mile Island and these other light water reactors are by design. Fukushima, you wouldn't have these issues because breeder reactors have fail-safe mechanisms that are non-meltdown. Okay, so it's so logical and so obvious, but why is there nobody doing it? It doesn't make any sense. And but again, there's so many papers already written out there on breeder reactor and how fail-safe it is and how it's so much better than
it's impossible to make the argument that it's not the best route.
Well, what are you going to do with all the lightweight reactors created? They only use like 3% of the energy in uranium in a lightweight reactor. That's why there's so much nuclear waste left over, because it doesn't use it. Where a breeder reactor uses almost all of it. It consumes 95% of the energy in the fuel versus 3% of the energy in a lightweight reactor. So, again, I wish there was this common sense it would be obvious what to do.
I made a joke the other day that, I get door-to-door salesmen for solar every day. I'm like, the second somebody shows up and they're like, we have an at-home nuclear reactor for you, I'm sold. Right. We'll put it in your garage and you're good forever. Like a warship. The next 50 years, you're free. Second somebody comes door-to-door with that, I'm in.
For decades, they've been trying to figure out how to store all this lightweight or nuclear waste material, right? That has a half-life of 250,000 years. It's called a breeder reactor. You get rid of all of it, and in the next 200 years, you could get rid of all of it by burning it in a breeder reactor, and then you would take
the already existing waste,
correct,
and use it.
It will fuel the breeder. Part of the fuel that you put in the breeder reactor, it can consume it,
and we know where it is. We
know where it is. It's already made, but the thing is, you have to change its storage container every 50 to 100 years, depending on how you're storing it, because the radiation breaks down the container. So for 250,000 years, you're going to store this nuclear material, or you could create a nuclear reactor that actually consumes the material.
I've heard the argument get made on how do you label nuclear waste? Because it has to be stored for 250 years. So you can't just put it in English, do not touch, because nobody's going to understand that in 250,000 years.
It's
How do you show its danger?
I guess you just put symbols on it, I suppose, that are universal, I suppose.
That was kind of the debate, was like, I guess spikes, like don't touch it, like it's bad.
Right.
But yeah, that's the whole other argument. I know this last year, Germany had their whole problem where they shut down all their nuclear and went back to coal, which seemed like a very weird move to do in 2023, 2024.
Again, I'm not sure.
That's more of like a geopolitical issue.
No, not so. I mean, again, back to the whole light water reactor nuclear is something that you really shouldn't build more of. It doesn't make sense. Again, doesn't make sense to build.
Yeah.
They should be building breeder reactors. And if they did that, that's where fission nuclear power should go for the foreseeable couple hundred. While in a couple hundred years, would we have fusion power capability in a couple hundred years? The answer is probably yes. But in the meantime, you're getting rid of the storage problem of highly reactive materials that were in light water reactors. You can get rid of all that stuff by using breeder reactor. But
it's like a 15-year thing to have one operational, as from what I understand, like 10 to 15 years.
It'd still be a fairly long time to get to the production of the.
So that's where I get frustrated, because if we're not doing this now, I have a 2-month-old son. If we're not doing this now,
right,
he's not gonna get to experience that.
No.
Like
he's not. No, I mean
it needs to be worked on yesterday.
Well, the designs exist. Okay, so
they're there. Yeah,
they exist. It's just that you have to get somebody. There has to be money focus behind it, or investment and focus behind it. And there's been some startups that try to move that direction, but again, it's back if you don't get the biggest corporations to buy onto this to do it, along with government saying this is the right direction, right? You just can't get change is the problem, and they would change it, and it's really unfortunate that with the most obvious solutions to problems don't get implemented.
Yeah, it kind of goes back to ExxonMobil. Where do they put their money?
Any one of these large corporations could say we're on board to do this, right? And they have the capital, right? They have the capital to actually go invest and do the long-term energy thing, where if you're moving away from the fossil fuel supply, then you're never going to get rid of all of it. You still got to have liquid fuels. I mean,
but electric cars start to make a lot more sense, in my opinion, too. If an electric car is plugged into a nuclear power plant, it starts to make a lot more sense. They don't make that much sense, but they make more sense.
The problem with pure electrics are, there's a thing we didn't even broach the subject, which is available materials to produce them. So that's the other big problem in electric car, is that there's not enough raw material availability to create all electric cars to replace all the internal combustion cars. They're just not. So this is why the cost of the cars are going up so much as you continue to produce more of them. It's putting stress on the supply side, and there's not enough materials. So that it continues to make them even more expensive. So again, it's not really the logical direction.
5,000-pound electric vehicles don't make any sense at all. That's just crazy. Like a scooter, like an electric scooter for commuting. Great. That's a very...
No, I mean, Toyota had it right. They were like, hey, we're just going to make hybrids. We're not going down the full electric route. They just put their foot down and said, no, we're not doing it, because they let common sense make the decision for them. They didn't just buy on to the thing that says we need to do this. And they're like, no, it doesn't make sense to do this. And they were the only one that said no.
I say all the time, Toyota completely nailed it on their first rendition of the Prius. They still are on the streets.
Yeah.
And they nailed it on that. And that, like the Prius
hybrid is the most, makes the most, it is the best payback of anything for efficiency that you can buy in a car for the cost.
Methanol of that, and then it's even more efficient.
And then you would just have a fuel cell. You fill your car with methanol with a fuel cell that runs an electric motor. And you can do that anywhere because it's liquid fuel storage. So that's really, maybe somebody will be listening.
Constant RPM. I know there's a few like small brand. There's Edison Motors up in Canada that's building like trucks that are diesel generator, but then electric motor to the transmission. So you get all the torque of the electric motor and you get the power, but then you have this just constant RPM diesel engine that can sustain. It overcomplicates things a little bit, in my opinion, because like you can just put a Caterpillar engine in there and run it for 500,000 miles and be done.
Yeah, I think that you could. It's probably not the best. Again, it's having available energy, right? So liquid fuels provide the best distribution, to remote areas, right? So in Canada, there's a lot of remote. Right, a lot of remote areas, so you don't get electric power everywhere you go, right? So how do you charge anything?
Yeah,
there's only almost the whole population's concentrated on the East Coast, and then there's a lot of stuff in between. You have to have a liquid fuel of some kind to transport.
But they don't use any batteries. They have no batteries. They just have.
Yeah, they're just running it directly, or maybe they have a small capacitance or small battery for energy requirement for accelerations and things like that.
Yep.
But yeah, it isn't. It's probably not a perfect solution for long term. Not sure what their motivation was to produce it, but there must have been some reason for that made sense.
Yeah, I don't know. I don't know what the long term goal is on that deal. I guess I think maybe just for logging, carrying very, very heavy things for short periods of time.
You have a very real, and they have a lot of natural resource type, mining, logging, you name it. They're doing that, and they need.
Because I guess an electric motor would be best in like stop-start, heavy material moving, I guess you could say, because it has that instant torque.
Yeah, I mean there's definitely benefits to electric motors in certain aspects.
Yeah. Somebody would have to educate me more on why they think that that's the best route to convert a truck like that.
Kind of why they like locomotives, right? They're essentially electric motors, but they use diesel engines to create the electricity to run the electric motor. So it's probably along the lines of very large vehicles needing to run versus having a direct drive line, transmissions and so forth, right? Because most of these are going to be direct drive without needing for transmissions, probably, is my guess. But that might have been the motivation.
Yeah, I had somebody that works on the power grids and he was telling me about how just the stop-start stuff, how bad that is, because the wind turbines are actually negatively impacting everything because it makes these small generators that take a lot of energy to start them up and then stop them again. It makes them more needed. So instead of their main plant that can just kind of constantly be rolling, they have these like auxiliary ones that have to start all the time. So it actually ends up being negatively impacting. It's one of those things where government tries to help and they end up not helping. I fear that happens frequently. If you boil things down.
If it were more effective at implementation of sound ideas. So it's unfortunately a lot of times influenced by investment monies, right? To decide
often the best intentions go.
Yeah, I don't know if they have an angle to produce money, right? So they go, hey, I want to be able to do this project, and you talk to their guy and said, this is what we want to do. So, yeah, I don't know. I wish we were more effective at getting these good ideas implemented.
Yeah,
and it doesn't seem to happen now.
I know it seems like the smartest people end up not working for where the ideas should be, and they end up
Right.
the smartest people usually have their own business somewhere and they're doing their own thing and they don't want any part of that.
Yeah, I mean, I don't know if that's real. I think that there would be, just that I think the system isn't well orchestrated today with how, you know, the ideas that get implemented at government level, right? It's all through lobbyists and so forth, right? So that's how that all the lobbying that happens to get something through.
Yeah.
It isn't. Yeah, there's where the problem lies. Is, you know.
We have a really weird situation in Florida right now where Lake Okeechobee, our main waterway, has been sprayed and sprayed and sprayed with like pesticides.
Yep.
And the government pays per gallon that you spray. They don't care how many things you kill. They don't care what any results, just per gallon. So you're incentivized to spray as much as possible. So Lake Okeechobee is completely ruined right now. So over the next 6 months, they're going to open up the waterways and flood it into the ocean and the Gulf. So all of this ruined water is now, right before summer, going to be flooded into the two largest water sources in the world, basically.
Yeah, that's interesting.
It's just kind of happened this last week where the Army Corps of Engineers decided that this is going to be their next step to try to fix the problem that they created, to now potentially ruin the Gulf of Mexico and one of the best fishing and wildlife areas in the country.
Yeah, there's
so I don't know how it's
commonly used slogan in the world of trying to do these things is the solution to pollution is dilution. So they're just going to dilute it into the ocean instead.
Just
right.
Send it off, and
that's what they do.
Well, and then the jet stream of like the stream is going to take anything that comes off the coast of Florida and bring it right up the whole east coast of the whole U.S., which is a shame.
Stream.
Yeah. It's just going to be right there, right across all the best beaches and fishing, and it's going to be an interesting few months on that deal. But
yeah, that's not. I mean, well, and then you have the waterways carrying that to that. So anything that's, you know, transporting that water isn't going to be great either.
Yeah.
So yeah, it's. Yeah, I wish there were better ways for that. There are ways, I think, but yeah, this whole thing with the chemical application of herbicides and pesticides that's a big problem. I say big problem, I mean it's a hard problem to solve, right? Because the system is set up to use all these things to produce all the things that people consume.
Yeah, and you probably understand too, because you're in Michigan, you're around the largest freshwater sources in the world. Right there. So I'm sure they're doing things that probably don't agree with up there across the board. And
yeah, I mean, we're, you know, I do have some farming experience too, so I don't use any herbicides or pesticides on my farm. So you can do farm, but the problem is it's not because you can't do that. The problem is that how do you get this massive quantities of production, right, without utilizing the system has been now set up to use these herbicides and pesticides, and how do you and can you get the same production not using those, right? And that's, I think, now the biggest problem to solve is for them is to go, well, how do we get away from these things? We know it's not good. You know, all these things are not good for people, the environment in general. How do you change the system to replace that? You know, and that's where the biggest hurdle is, I think, now is how do you get away from that?
Well, the farmers are standing up as much as they can. I mean, and then they had all their problems with nitrogen shortages because DEF is basically taking all of it, which is a whole nother rabbit hole that I go down all the time, is my hatred of DEF and boxes and plastic and this and that, and the DEF in itself is a frustration.
Well, I mean, I guess I don't understand that part. What's the frustration with the DEF?
It's hard on the cars. Like it's a corrosive thing, the DEF fluid.
Yeah.
And then when you buy it in a box with a plastic jug, and then a plastic straw, and then a plastic bag, and then that's supposed to be the best route to help your emissions. But then you just kill your catalytic converter and your
I mean, on diesel is that obviously you need it to be able to clean up the emission side of things. I mean, it does work. It isn't versus. Then you have particulate issues, right? So part of that, you have particulate emissions to deal with on diesels, and then you have but urea is obviously, this is kind of what got VW into problems, is they tried to come up with a solution that would not utilize DEF. And they do have some systems out there. They're not as efficient. So what you end up doing is burning more fuel. So what's the worst enemy, right? So you can burn off the particulate trap and not use urea, right, is what you're putting into this. That's what DEF is. It's basically nitrogen fertilizer.
Yeah.
Essentially, to use in this reaction.
Yeah, it's just fertilizer.
Right, it's essentially fertilizer, nitrogen fertilizer. And if you don't do that, then you use a lot more fuel. So the engine becomes less efficient because you end up with high nitrous oxide emissions when you don't use DEF. And so you can modify the engine, but now you reduce your fuel economy by 15 or 20% when not using it. So you can build engines that don't require it, but now you're burning more fuel. So which is the bigger enemy? Burning more fuel or using DEF?
Using DEF, and then also all the components, failures, and stuff that goes along with it. Because I know engines on DEF are not lasting 300,000 miles like the diesels of the past. Their failure points are vast.
Yeah, I don't have any information.
Just sensors
on that
and stuff
one,
like that, and
yeah.
Diesel particulate filters have a very short service life compared to the stuff of the past.
It is cleaning up diesel. Again, if you were to move away from, you could convert diesel engines into other types of fuels. It's been shown that you can do that. Back to changing the fuel source, right? Again, why is diesel so favored? Well, because of its energy density and the efficiency you can get from the engine. But it could be changed. I mean, so that you have less of those issues. Durability, obviously, maybe different products could be developed to make it more durable over time. My guess is that they get better at it all the time. But I think you have multiple problems you're trying to solve. So the solution wasn't necessarily the perfect solution, but it was better than not having DEF solution, because now you clean up the nitrous oxide emission and you get the fuel economy, right? So back to fuel economy, right? Yep. So can you get the fuel economy?
Can I pause you for a second? Yeah. Well, we can only hope. Well, we've been cooking, man. This was really fun. I had a really good time. This was super enlightening. I would love to have you back on at some point, but I'm sure the comments will be overwhelmingly have him back on. We want to hear more.
I have a place here in Florida, down in Venice. So not far. So it was an easy drive. I was only like 35 minutes to drive up here. So
awesome.
So we could potentially, if it has a positive impact on your podcast, I'd do another one. It's an interesting conversation. I don't find too many people actually want to talk about the things that we just talked about, though. So most people are just like, they have their mind set up about these things that they have their, the talking points down, and these are, I'm like, man, I wish you would just open your eyes. You're not seeing the.
I appreciate you coming on here and enlightening me like that. I hope a lot of people get some stuff out of this. I'm sure people that are listening to it will be pretty eye-opened by a lot of it, and I know for me, I do all this stuff for me anyways. I just have interesting people on that I want to talk to, and then I just get to put it out to the world.
Put it out to the world, and people will look at it. Yeah.
So that's my goal with this whole thing. But man, I'd love to have you back anytime. Anytime anything's interesting going on, anything you want to come and talk about,
and talk about some
other
stuff
people
in the future,
we can have on. Like I kind of set this up to have 4 people on. So if we wanted to have like an actual discussion,
discussion.
Yeah. So I'm always open to anything, man. But that was super awesome. I know the last bit wasn't about Tial, but check out Tial. Your website, social media, all that kind of stuff will be in the description. But thanks so much for coming on, man.
All right.
That was awesome. We'll see you guys next time.